Covalent bonds. Covalent bonds are the stable balance of attractive and repulsive forces between atoms when they share electrons. In other words, it's when two atoms, like the picture represented here, hydrogen and carbon, share their electrons, more specifically valence electrons. An easy example to remember would be the bond between hydrogen and oxygen to make water. And it's easy to remember because their bond looks somewhat similar to Mickey Mouse.
Covalent bonding was a concept first discovered, or rather given credit to, by Gilbert N. Lewis. In 1916, he described the sharing of electron pairs between atoms and introduced the Lewis dot structure. In 1919, this man named this bonding as covalence in an article that he had written.
In 1927, two men, Walter and Fritz, were given the credit for the first successful quantum mechanical explanation of a chemical bond.
A nonpolar covalent bond is a bond between two nonmetal atoms that have the same electronegativity and therefore have equal sharing of the bonding electron pair. A polar covalent bond is a bond between two nonmetal atoms that have different electronegativities and therefore have an unequal sharing of the bonding electron pair. The molecules in covalent compounds don't interact with each other much, making them easy to pull apart from each other. Since they're easy to separate, covalent compounds have low melting and boiling points when compared to ionic compounds.
Covalent compounds are soft and squishy. This is because their molecules can move around each other very easily because they have no bonds between them. As a result, covalent compounds are frequently flexible rather than hard. You can think of it in this way. They have plastic ball pits at fast food playgrounds for little kids. While the balls themselves are held together very tightly, the balls aren't really stuck to each other at all. As a result, when little kids jump into the ball pits, they sink in rather than bouncing off.
Covalent compounds tend to be more flammable than ionic compounds. Since carbon and hydrogen have very similar electronegativities, they are mostly found together in covalent compounds. As a result, more covalent compounds than ionic compounds are flammable.
Covalent compounds don't conduct electricity in water. This is because there are no ions in a covalent compound.
Covalent compounds aren't usually very soluble in water. Since water is a polar solvent and most covalent compounds are fairly nonpolar, many covalent compounds don't dissolve in water.
The octet rule states that atoms tend to gain, lose, or share one or more of their valence electrons to achieve a filled outer shell. Now, their outer shell can fill 8 electrons. If you know how many valence electrons an element has, then you know how it can combine with other elements. For example, in group 1, they have 1 valence electron, so the capabilities for bonding with other elements is higher than the last group where the noble gases are, and the noble gases cannot bond with any other elements because they already have 8 valence electrons. The same thing can be observed by knowing the electron configuration of an element. By knowing the electron configuration, you know the number of valence electrons in that element.
The simplest way to represent and describe molecules is to use the Lewis structure. The Lewis structure model generally follows the octet rule and provides a framework to understand covalent bonding. Lewis structures represent valence electrons as dots and bonding electrons as lines. Lewis structures do not represent inner electrons, only valence electrons are shown.
These steps listed here describe how to draw a Lewis structure. This is an example of what water would look like when drawn out in a Lewis structure.
Yeah.